So here we go with this assignment. Sorry for the delay on this video, but Blink shut off right here. Um, if you click on this link, it's going to send you here. And this totally tells you about how to make a button like this act like a switch, which means that demonstrates the use of a push button as a switch. Each time you press the button, the LED or whatever you want to turn off and on turns on and off by just toggling back and forth. It says a push button on pin 2 and LED on pin 13, and you can tell that just by reading this code because when you go to void setup right here, there's only two things: pin mode in and pin mode out pin, and then of course one's an input, one's an output. Then you go over here and you're going, what is in pin and what's out pin? They define them right here as variables, and it's pin 2 and pin 13, and they note it right here anyway. So yeah, so what you would do is you would get your Arduino and go over here, go to Arduino and get a breadboard. And of course you're going to need to go to basics and get a button. And you always put the button right here in the middle. You don't want these legs on this side to touch these legs on these side. You want them all separate. So now you have this leg all touching this row, this leg is touching this row, this leg is touching this row, this leg is touching this row. They're all isolated. Of course we're going to need an LED. We'll go ahead and get that out there. We need one resistor for the LED usually, although technically it's using pin 13, so we wouldn't have to, but it's always just good practice. Why not do it? I'm going to move this LED up here, and that way I have a little bit of space. This button, you do need a resistor for it, and we're gonna use what's called a drop-down resistor, meaning it's dropping down to the ground. When you use a positive, when you stick the positive, it's called a pull-up resistor. It pulls up to the positive, but we're going to be using the ground, so it kind of defaults back to negative every time. And when you do that, I'm going to take a pin 2, because that's the button pin, and just put it here for now. And then I'm going to run it over here just so it looks nice and neat. We're not just dropping it across. So this pin 2 is connected to right here. And if you look, it's always going to get this negative. See, it comes right here and goes here, always. So this ground, this whole row has ground. You can tell it comes all the way back to this ground over here. And it goes here, goes in this resistor, comes out, goes in here, and goes here. So it's always going to have ground, which means it's always 0 or always off. So we need a way for this to turn to positive when I click on it, right? So we're going to take a positive wire in this row and just run it down to the positive. So we have the positive goes to this row here. And now whenever you push this button, that connects these two, this one to this one, and this positive can flow through here and just kind of flood it in and go this way. And some of it will even trickle through here and go to the ground, but the majority will be positive, obviously. So this is a 1000 ohm resistor, 1K. This is an LED, so we can totally just make this one like a 330 if you want. 220 works, 330, something like that. That'll all be fine, and it'll work. And then this right here is going to be ground, so we can go ahead and stick that into the ground. Or actually, ground is right here, isn't it? We don't have to go all the way back there. So here's ground, right here, and here's our pin 13 signal. And that's it. That's all the wiring that you'll need to make this happen. And when you went to the assignment and you clicked on this, it sent you here, and the code's actually already all here. So you can totally just copy and paste it unless you want to type it all again. A lot of this is all notes, like this whole section up here is all notes. But let's go ahead and paste it in here. So let's go to the code. We don't want blocks. And delete out all this stuff. So make sure you do that first. Just make sure this is clean and delete it before you paste this in. There we go. And I like it's all colored. So here's a bunch of notes here. You can leave it in there. It just tells you what it does, or you can delete it if you want to clean this up a little bit. These are all just notes to help you out, telling you what each line does. It doesn't tell you what these do, but you already know what they do. These are just pin modes telling the Arduino whether you're going to use the pin and what pin you're going to use it for. You can use it as an input or you can use it as an output. then there's this code right here. So all the action is right here, and it says reading. So that's a variable that was made up here. Okay, the current reading from the input pin. So that's what it is. You can tell. See, digitally read in pin, and it sets it to this variable here. And if that's equal to high, and the previous is equal to low, and millis minus time is greater than the debounce. Now this one's really complicated because they're adding some debounce code in here, and what that is when you go to click this in real life, when you go to click it, if you can like zoom in with a microscope and see where the where this connects these two pins together, and you can look in with a microscope and a super high-speed camera, you'll see that when it clicks, it might click 2 or 3, 4 times, like at the microscopic level. And these things are so fast, they'll pick up every single one of those. So it'll toggle off and on and off and on. In fact, it might do it an odd amount of times, and then it turns off when it should have turned on. If it did an even amount of times, then you're lucky and it did what you're supposed to do. But it would kind of like act not smooth. So this adds some debouncing. In fact, you can actually play with the debouncing right here. It says the debounce time increase if the output flickers. So if you're having a pain with this thing and it's flicking in real life, so you're not doing this in Tinkercad, but in Tinkercad it's always going to work because there's no debouncing in this thing. When you push it, you push it. But in real life, you might see some flickering or acting weird. So you can totally try to put this at 20 or 30, 40, 50, but you can bump it up to as high as 200 or even more if you want, if you're trying to like just debug this thing and make it work right. And then it just says, and then once this is all true, so that way it's going to push it for you. It just says state, if state is high, set the state to low. Otherwise, set the state to high. So this is where it just toggles, either turns off or turns on. It just says, hey, if it was on, then turn it off now. Otherwise, turn it on because that means it was off. And then set time to milli so it can record the time that's stamped when this happened. So that way it can check the millis later on, and it can check the previous and the time and this time right here, and it does this math to see how long it's been since it's been clicked last. Because if you click it and it does a little quick double click, like you didn't even notice it did that, it won't click it again because the time hasn't passed by. So you don't have to worry about that. And then that's it. And then obviously it writes to that pin, this LED pin 13. It writes to the 13 pin, and it writes it with the state, whether the state is either low or high. It's going to toggle it back and forth depending on what it was. And then previous, set it to the reading. So this is all part of this time stamping, and this is all part of this time stamping and recording to make sure that the debounce works correctly. So this is not a lesson on debouncing. That's why I'm allowing you to just copy and paste this in here. But just know that those things like this is just all it's doing is stamping and recording when things have occurred, so that way it won't do this again, this part where it toggles it. It won't do it again until that amount of time has passed, this debounce time right here, this 200 milliseconds. So obviously if you like to turn it off and on faster than 200 milliseconds, this wouldn't work, but who really wants to, right? I mean, if you just want to click this and turn it off or on, let's see if it works, by the way. So it's on, and then I click, and it turns off. Click, and it turns on. And if I walk over here again, click, it should turn off. So it's just toggling back and on. But if I click and click again, actually it worked fine. If I do it too fast. In real life, I don't know how this is going to work in Tinkercad. In real life, if you try to do it less than this, it won't work because it's going to think it bounced, so it's not going to read that second click, so you might want to reduce that. But I don't see anybody ever wanting to turn this off, then back on again within 0.2 of a second. That's 0.2 seconds. That's pretty fast. So that's all there is to it, and hopefully you guys can do that. If you guys have any questions, let me know.